looking at notes over inverse graphs. So before I begin, I want to say that I will be speaking quickly, so you probably won't have time to copy it all down as I'm speaking, so you will probably have to pause the video often. So just a bit of a warning there. Make sure that, as you always do, as you are expected, get down everything that I have exactly like I have it. So let's start with Roman numeral number 1. So the parent function, f of x equals sine of x. When we looked at the parent function, remember, we looked at just this portion of the graph, one cycle, one period from 0 to 2 pi. But as you know, this graph is continuous. It goes on forever. It repeats forever in both directions, in the positive direction and in the negative direction. So therefore, the full graph doesn't have an inverse function. Of course, it has an inverse, but not an inverse function. It fails the horizontal line test. So remember from Algebra 2 that something like a quadratic graph, since this graph is not 1-to-1, it fails the horizontal line test, that graph would not have an inverse function. Remember, a quadratic graph's inverse is both the positive and negative version of a square root graph, and that doesn't pass the vertical line test. So the inverse is not a function unless you restrict it. Similar to that, we will be restricting the sine of x parent function to a certain interval. That way we can have an inverse function, not just an inverse, but an inverse function. So like always, we want our sine graph to be as close as possible to the origin while still being a function, the inverse being a function. So when we look at the interval that we're going to choose, we're going to choose the interval to look at the sine graph from the interval negative pi over 2 to positive pi over 2, because within this region, that graph is 1-to-1, meaning it passes the horizontal line test. So that is the region closest to the origin that passes the horizontal line test. If I would have chose this section here, that section doesn't pass the horizontal line test. Likewise, if I would have chosen this section, that section doesn't pass the horizontal line test. So this section here does pass the horizontal line test, so the inverse with these restrictions would give us a function. The inverse would be a function. So it has an inverse function on this interval. The 3 points we're using are negative pi over 2, negative 1, 0, 0, pi over 2, comma 1. Remember, to get the inverse, you will switch the x and the y's. So negative pi over 2, negative 1 will switch to negative 1, negative pi over 2, 0, 0 stays 0, 0, and pi over 2, comma 1 becomes 1 pi over 2. So the inverse, let me unveil its beauty. The inverse of sine inverse of x, or you can also see it written arc sine of x. Either one of these is acceptable. Either one of these two is fine. The inverse looks like so. So one thing I want to point out, other than the graph and how it looks, is that these points here are end points. They are closed circle. We are going from the interval negative 1 to positive 1 inclusive, and then the range is from negative pi over 2 to pi over 2 inclusive. And the only reason I'm pointing that out is because, as you are probably well aware, that will come back in the future. Okay, so now that we've talked through that, we're going to go through the rest pretty quick. So similar for the cosine, f of x equals cosine of x graph. The full graph does not have an inverse function because it fails the horizontal line test. So this is our cosine of x graph. Of course, again, it goes on forever. Obviously, I'm not going to do all of the entire graph. Unlike the sine graph, I can't choose this section that's closest to the origin here from negative pi over 2 to pi over 2 because that interval fails the horizontal line test. So for cosine of x, we will choose the interval 0 to pi. This section from 0 to pi would pass the horizontal line test. So we have an inverse function on this interval from 0 to pi, and our 3 points are 0, 1, pi over 2, 0, pi, comma, negative 1. So of course we switch the x and the y's, as you can see we've done here, and then to unveil the inverse function, we have f of x equals cosine inverse of x, or f of x equals arc cosine. Make sure that you do put two c's, arc and then cosine of x. And this is what, if we plot these points, of course, this is what we have. We have 1, 0, 0 pi over 2, and negative 1 pi. And again, look, pay attention closely. These are end points. They are closed circles. Okay, so give you a second to copy and pause if you need to. Make sure you have everything labeled, etc., etc. So we're getting to the last one here. Okay, our tangent graph. F of x equals tangent of x. Of course, you know this graph very well. You did it on your test recently. So, of course, also like the other graphs, this is a continuous graph forever. I didn't draw the entire thing. Obviously, I cannot. It goes on infinitely. So we are going to choose, as we've done before, the section closest to the origin. And from negative pi over 2 to pi over 2, this section of the graph is 1 to 1. We pass the horizontal line test as long as we don't use anything outside of those bounds, just everything within those bounds. Okay, so we have an inverse function on this interval from negative pi over 2 to pi over 2, so make sure you get that in there. All right, just like on the other ones. And here's what's really special about this graph. So when you look at the point, the 0, 0 ordered pair, of course, just stays 0, 0. And we don't really have points here. We don't have whole number values or anything that we've slated out as an ordered pair here. But you do know your x's are positive, your y's are positive. So, and they're going to switch. So then, of course, you'll have y comma x, so it would create this type of graph here. And then similar here, this will become like this section. So we have our tangent inverse of x graph and our or arctan. You can call it either way. Either one of these is acceptable. What I want to point out here is that we have arrows, and we have this undefined region on pi over 2 and this undefined region on negative pi over 2 in the range. So just be aware when we start talking tomorrow, this is where the undefined section of the tan inverse graph comes from. So that will come back tomorrow.